In this video, we're going to talk about the reciprocal trig functions, the inverse trig functions, and how we can evaluate them using the unit circle. It's really important to keep in mind that the reciprocal and inverse trig functions are totally separate. They are not related to each other, and they are often sometimes confused. So again, reciprocal trig will cover first, and then inverse trig will cover second. Okay, our three reciprocal trig functions are cosecant, secant, and cotangent. Cosecant can be found is abbreviated as CSC of some angle, and we can find this by doing 1 divided by the sine value of that same angle. Another way to think about this is, since sine is the y value, you can think about this as 1 over the y value. Secant, abbreviated SEC of an angle, can be found by doing 1 over the cosine value. Cosine we know is x, so 1 over x. And then cotangent is abbreviated COT of an angle, and that's 1 over the tangent. So all of these are reciprocals because it's always 1 over the trig. So 1 over sine, 1 over cosine, 1 over tangent. And another way to think about 1 over tangent, well, we know that tangent is sine over cosine, so the reciprocal of that is going to be cosine over sine, or x over y. So these are the definitions of the reciprocal functions, and we'll talk about how do we evaluate these functions using the unit circle on the next slide. Okay, the first example that we're going to do is secant of 45 degrees. So first thing I'm going to do on my unit circle is find 45 degrees. And then I'm going to remember that secant is 1 over the cosine value, or 1 over x. So to evaluate the secant of 45 degrees, I'm going to go 1 over the x value at 45 degrees, which is square root 2 over 2. So to do 1 over a fraction is just to find the reciprocal of that fraction. So I'm going to take and do 2 over the square root of 2, reciprocating that fraction. In other words, swapping your numerator and denominator. And then this is pretty much my final answer. You just can't leave the square root in the denominator, so I'm going to rationalize by multiplying square root of 2 top and bottom. So I'll have 2 square root 2 over 2. And I can simplify down to the square root of 2. See how many of these you can do on your own, and pause the video and try as many of them as you can. Okay, check your work. Couple things that I want to point out. Make sure you're remembering the difference between 0 on the denominator versus 0 in the numerator. 0 in the denominator is an undefined value, whereas 0 divided by 1 is 0. Other things that I think that it's important to keep in mind is when you are rationalizing the denominator. So anytime you have a square root in the denominator, make sure you rationalize that by multiplying by whatever the square root is in the denominator, top and bottom. And then again, just making sure you're doing your reciprocals. So 1 over 1/2 becomes 2 over 1, just 2. And then again, anytime you have any operation outside of the trig, you kind of do the trig part first, and then any operation that happens after the trig gets applied second. So that's it for these examples of reciprocal trig functions. If you have any questions, please make sure you ask and attend office hours or ask questions. Okay, different from the reciprocal functions, you also have your inverse trig functions. Your inverse trig functions, on your calculator, you'll see them as like sine to the -1, or cosine to the -1, or tangent to the -1. These are also sometimes called arc sine, arc cosine, or arc tangent. So just another way of saying that. Your calculator buttons, you will see the -1 notation, but both of these will work. And essentially, inverse trigs take a sine's y value. so the y value, and returns the angle that happens. So inverse trig, you're thinking about using this these unit circle backwards. You have a y value and your answer is going to be the angle, or you have an x value and your answer is going to be an angle, or you have an x divided by y value and your answer is going to be an angle. Okay, our inverse trig functions are used in two ways. First, they're used to solve equations. And whenever you're solving an equation, you're always using the undoing or the opposite. So these trig inverses are kind of like finding the answer to a trig problem. Like here, we know that sine of some angle measurement is equal to 1/2. So the question is, what angle measurement can I put here so that I will get a 1/2 answer? Well, sine we know is our y value. So here is a y value of 1/2. So I can put 30 degrees in for my theta value. So theta could be a 30-degree angle. But if you also remember back from when we were doing our ambiguous case of sine, the other value where you could have a angle measurement where the sine value, sine of 150 degrees, could also be 1/2. So this theta could also be 150 degrees. So whenever you're using sine in reverse, that's kind of what you're doing. You're doing a sine inverse problem. If they ask you to solve an equation, you're going to want to provide all angles that are possible. So here we have two solutions. But for functions, we don't ever want to have more than one output to a function. So because of that, whenever they ask you to evaluate an inverse function, this is pretty much saying the same thing. You're saying sine inverse of 1/2 is the same thing as this question over here, but now instead of having two answers, we're going to use a primary answer. The primary answer that we'll always use is going to be the one according to the limited range. So sine has a limited range value that will allow us to only be a function. So we'll only put out one degree measurement or one radian measurement for our answer. So here we want to only use angle measurements from -90 degrees to +90 degrees for sine inverse. So even though 150 answers the question over here where we're solving the equation, when we say sine inverse, we're only going to return the one that is in the appropriate range. So sine inverse of 1/2, we would say is 30 degrees. You can also type this into your calculator in degree form, and it would only return 30 degrees as your answer. So whenever it's doing sine inverse, you're looking for the limited ranges. So again, sine inverse has limited ranges in both degrees and radian form, and then cosines, limited degrees and radians, and then tangents, degrees and radians. These are their range value limitations. Okay, we're going to do these 4 problems. The first is asking us to solve an equation, and the second is asking us to evaluate some inverses. So again, remember whenever you say solve, you want to find any possible angle on the unit circle. Okay, so the question is, what angle measurement, so sine of some unknown beta angle, is equal to 1. So what could beta be so that the sine value is 1? Well, sine we know is the y value. Y value is 1 at 90 degrees, so beta could be a 90-degree angle. For tangent, that's a little bit harder, but we know that tangent is our y divided by our x coordinate. And I want to know at what angle measurement can I get the y divided by x to be 1? Well, in order to get 1, I need something divided by itself. So I'm looking for the angle measurements where the x and the y are going to be the same. At 45 degrees, the x and the y values are both square root 2 over 2. So when I divide those, I would get 1. So beta could be 45 degrees. And beta could also be 225 degrees, because when I do a negative square root 2 over 2 divided by a negative square root 2 over 2, that would get me 1 as well. So again, whenever you're solving for an angle, you want to provide all possible angles. Sometimes you'll have 1, sometimes you'll have 2. You can technically have an infinite because you can continue to rotate beyond 360, but we're going to be looking for ones only that fall on our unit circle for this unit. Number 2 says to evaluate cosine inverse of square root 3 over 2. So I want to find, when does cosine equal square root 3 over 2? Well, there are 2 places where that's going to happen. Cosine, if you remember, is the x coordinate. So here is 1. And the other place that cosine is square root 2 over 3 is at 330 degrees. However, when I'm doing the cosine inverse, I only want to return the one in the appropriate range. Cosine's range is 0 to 180 degrees. So the angle measurement that I will use for this answer will be a 30-degree angle measurement. For the second problem, I've got sine inverse of negative square root 2 over 2. So sine is my y value, so I'm going to find those negative square root 2 over 2 and negative square root 2 over 2 for the sine value. That gives me 2 angles. My 2 angles are 35 degrees, or 315 degrees, or I can use 225 degrees. However, if you remember, our range for sine is it can go from negative 90 degrees to 90 degrees. So neither one of these angle measurements fits into that range. But one thing we can remember is a negative angle can be formed by rotating clockwise. And so this 315 degrees is the same angle measurement as negative 45 degrees. This does fall in my range of my sine inverse function. So my sine inverse value of negative square root 2 over 2 is going to be negative 45 degrees. Notice here, for both of these, we only have one answer. Negative 45 degrees is the only answer for the sine inverse of negative square root 2 over 2. And 30 degrees is the only answer for cosine inverse of square root 3 over 2. There can only be one answer for a sine inverse or cosine inverse problem, so that this will remain a function. Okay, that's it for the inverse and the reciprocal functions. Give the extra practice a try and see what questions you have. We're available during office hours and to ask questions.